Welcome to TOC class. Here the concept of automata theory part contains grammar. So already we know about alphabet, strings and the operations performed on strings and how to frame a language. So these are all the concepts of automata theory, and the fourth concept is grammar. A grammar can be defined as a set of rules. So what is the usage of rules? These rules are used for helping for defining a language. So the definition of a grammar is a grammar of a language is defined as G. It is a symbol which is denoted for a grammar G. G contains 4 parts in it. V means variable or non-terminals. T means terminal symbols. P means productions. That means the productions are written as rules. And S means the starting state of a grammar. So this is an example for grammar. Here we will discuss few problems behind those concepts. It is already discussed. Just be aware that whether we know about these concepts or not. So given an alphabet set sigma, which contains 2 symbols AB, obtain sigma star. So what is the meaning of sigma star? Sigma star is equal to sigma power 0 union sigma power 1 union sigma power 2 union sigma power 3 ... like that. So what are the way of framing a language? There is no conditions given in this set. So see, there may be the possibility of any notations for sigma star. So sigma star is nothing but L. So L is equal to sigma star. Sigma star means clean closure. So there is a possibility of empty string. Single length word means AB. Two length means there may be the possibility of AA, AB, BA, BB. Three letter means there may be the possibility of 8 letters. Like that you can able to write sigma star. So this is the first question's answer. Second one, for the given language L is this language is generalized form. So how can you expand it? Substitute n value as 0 in this generalized notation, n value 1 in the generalized notation. First you write the possible strings in this language. So how can we write it? L is equal to, if you substitute n is equal to 1, a power 0, p power 0. That means there is no possibility of a and b, so only epsilon is possible. If you substitute n is equal to 1, a, b string is possible. If you substitute n is equal to 2, a squared, which is written as a, b, b. 3 means triple a, triple b. 4 means 4a followed by 4b. So these are all the way of strings which can be framed within this generalized form. That is a power n, b power 1. First you write the possible strings. Then you check. What is the checking conditions? Whether the string AABB is available in your language. So just you check it out. Equal number of A's followed by equal number of B's. It is in a generalized form of A power n, B power n. So the first string is available. If you take second one, there is no equal number of A's and B's. So it is not available in a language. So this is the answer for the first one. And second one, L is equal to A power n, B power n for all n greater than or equal to 0. We already write the language concept. Find L to the power R. So R means reverse of a string. L to the power R means reverse of strings in a given set L. So what all the strings are available, you write it as a reverse order. So if you take L to the power R equal to, if you reverse epsilon, the same epsilon is there. AB order reverse BA. Double B reverse is double B, double A. Like that triple B, triple A, 4B, 4A. So we can able to write it as a generalized form. That means B power n, A power n greater than or equal to 0. This is the answer for second one. If you take third one, U is equal to, this is a string A squared, B, A cube, B squared. Either you can write it as powers or you can able to write it as WAB, triple A, double B. Like that. UV means concatenation. So concatenate V at the end of U. So the answer is A squared B, A cube, B squared followed by BA. B squared B is B cube A. So you can able to write it as. The second one, U V squared. V squared means V 2 times. V squared means V into V. So the first V answer is BA followed by BA. It's not B squared A squared. It's only BA. So after we squaring V, then you append that V squared answer at the right end of U. Then mod UV means the length of the string. So like that, the answers are available. And the last concept is graphs. We already write the rules with the help of grammar. Graphs are used for implementing those rules in a diagrammatical way. So a graph is applied with formal language. You can also implement that graph in a compiler writing and artificial intelligence concept. So a closed formation of graph is called a cycle. So here a graph is listed out. A graph which has no cycle. No cycle means there is no closed path from V4, V5 or V5, V6. If you close V4, V5, it is framed as graph. If you close the path V5, V6, this is also framed as graph. But we can also frame tree. Tree means a graph with no cycle. So this is a tree. So a tree contains some predecessor and successor is there. In this diagram, the tree is called as binary tree because maximum children is 2. So in this binary tree, predecessor means the parent of the current node. Successor means the children of that particular node. Here V1, V2, V3 are denoted as nodes. The V2 parent is V1, that means V2 predecessor is V1. V2 child is V4, that means V2 successor is V4. So here example, successor of V1. Successor of V1 means children. So V2 and V3. Successor of V2, there's only one child, that is V4. Predecessor of V2 is V2 contains only one parent, so it is denoted as V1. So these are all the concepts of automata theory. There are 5 different concepts: alphabets, strings. Strings can be framed for language. Language contains rules that will be framed with grammar. The grammar rules can be described as a diagrammatical way, that is called as graphs. And how can you prove the theoretical part? So that is called as proofs. So proofs comes under 3 categories: formal proof, additional forms of proof, and inductive proof. So if you want to try to find a solution in a theoretical way, there are generalized notations are available. So formal proof contains some conditions. Conditions are called as hypothesis. And if you try to find a solution, that is called as conclusion. So all formal proofs are comes under hypothesis conclusion part. Some mathematical formulas are available. For example, sum of first n natural numbers, sum of squares of first n natural numbers. So these are all the series. These series contain some formulas in it. This will be proved under induction proof. So these are all 3 different categories which will be discussed in next class. Thank you.